But we had Bena. Bena made sure that no one can get into the cluster, the image, if it's not signed by us. And Falco will catch something there if there is shady activities. And we have network policies. Who can talk to anyone if we don't allow it? And the pod doesn't have any capabilities. Let's see how tight it is. Live demo. But before we get to it, I need to give you some context of what we are talking about. So the structure is that we have one app, which is version 1.0.0. And this app is a simple app which draws a box, right? And it uses a library box, also version 1.0.0, which that guy uses two different libraries, D and pad, which does different jobs for that. The point is that you need to see here is that these D and pad guys are leaf dependencies. So the app sees that I am dependent on the box. The box is dependent on the D and pad. And what we are going to do is that we have a Kubernetes cluster. We have a demo namespace. We have a kube system namespace. We have the CoreDNS in kube system namespace. And our app is only and only allowed to talk to CoreDNS of its own cluster. And normally, when you ask the DNS server what is apis.google.com, if it doesn't know, it asks upper. If that guy doesn't know, it goes upper, and it's most fascinating distributed system DNS and most useful when it comes to hacking. What is happening is that if you ask for apis.google.com, you go to a normal DNS. But if you ask for a subdomain of it, it goes to my evil DNS server. With that in mind, let's get to the demo. And I hope that everything is working. So, let's do it. Anyone can see it good? Is it good? Oh. Enter doesn't work with this. Enter. Yes. So, first, let's see the dependency tree that we talked about. As you can see, we have the same dependency tree that we talked about. Let's see the pod status. So we have one pod which is running right now and running the app version 1.0.0. Let's see the policy standard status. On this namespace demo, we can see that it's enforced restricted. And let's see the network policy status. We can see that all the traffic is blocked. Only traffic is allowed is 53 to any pod that it has a kubeDNS label, which is the CoreDNS. And let's see the Kyverno status. Yeah, it's there. It's sitting for admitting any new thing that it comes on its way. And let's test Kyverno. We tried to deploy something that it's not being signed by us, so it's being blocked. Let's see if Falco is there. Yes, Falco is running. Let's test it. Let's sh open a shell to our pod. We get a notification. Falco detected the syscall is being called, so Falco is watching. Let's introduce our malicious code. So now is the time that Rika, with his friends, they introduce the new updates, and whoever gets the update is going to get infected. And we are watching the Falco also in the same time. If anything goes wrong, if Falco detects anything, we will be there. And you can see right now that the application is being updated to 1.0.1. So we have a small patch update. Let's run the CI pipeline and deploy our app to the NPM registry. Obviously, the NPM registry is on my machine right now. And we get a green pipeline. We built our app. We pushed it to our registry. We pushed it to our Docker registry, which is local also. And now let's deploy. You can see the pod is running. We're going to deploy our pod to Kubernetes. The old one is going to be terminated, and the new one is going to come up. And now our new pod is there running. And now let's run my evil DNS server, which I made it pinkish for being hackery. And there, if you remember, this pink one, couldn't find the same color, but is the guy that if any request comes and CoreDNS cannot find it, it will happen. So let's send a curl request to our pod, simply to draw a box for us. The first request, sending. As you can see, we got the result, the box is drawn, but the hacker is getting a lot of requests from our pod. And Falco is silent. We saw that there is network policy. You cannot talk to anyone. How this traffic is slipping out. So it goes on and on and on because it's sending chunks of data very slowly. And on my side, I will pack together this data, which you can see. There is a part that it's a jargle, which that jargle is base 32, and then it's .apis.google.com. So those jargles, if you put them together, you get the service account token of Kubernetes. You can watch my another talk about the DNS tunneling. I will go through in details there. So, yeah, everything went good.